Hi, I am Arib. You are watching my YouTube channel. What is transformer protection? Rare as they may be, internal faults in transformers can progress to cause significant damage to the device. Transformer protection is a catch-all term that can apply to any number of protective enhancements and additions you can add to a transformer. These systems work to find internal faults in a transformer with varying degrees of sensitivity, and some can additionally provide backup protection in the case of a fault. These systems can sense varying factors, including current, voltage, frequency, oil pressure, and temperature. However, not all transformers will include the same protection systems. Many facilities need to take into account their budget and determine the most important protection systems to include in a given machine. In many instances, there are certain varieties of faults that are more likely to occur than others. These should be given priority when designing a transformer's protection systems. When choosing protective systems and determining which are worth including, you cannot forget about the possibility that transformer failure could result in damage to nearby pieces of equipment and infrastructure. Finally, it is essential to consider the cost of the protective device in comparison to the cost of replacing or repairing the transformer. For many budgets, there comes a time when it costs more to install more protection than it would to repair a transformer. All these factors must be considered when choosing which protective systems to use. Why is transformer protection important? We have already touched on some of the financial incentives you may have for keeping your technicians in the know about transformer faults, but there are also other considerations. For instance, a fault can affect your bottom line in more ways than replacement costs, as downtime is also an expensive proposition. Protection is an essential feature used to keep the time of disconnection to a minimum and to reduce the possibility of catastrophic failure. The longer you have a transformer that operates in suboptimal conditions, the more likely you are to compromise the lifespan of the transformer. Common types of transformer protection systems. Overcurrent protection. When phase or ground faults arise, you are going to want overcurrent protection. In safe conditions, electricity flows without generating any excess heat and simply provides power to the transformer. When this flow exceeds the normal amount, transformers can overload or short-circuit. The simplest means of providing overcurrent protection is with fusible links, fuses, and circuit breakers. All these pieces of hardware can limit or even disable the flow of an electrical current. Keep in mind that this hardware will not correct the overcurrent problem. Instead, they will stop the flow of electricity by tripping circuit breakers and blowing the fusible links. Overheating protection. As you may imagine, one of the biggest problems that protection systems need to be aware of is overheating. Whether the overheating comes about due to a short circuit or an overload, either possibility can be devastating. In most cases, the maximum temperature in a transformer is around 95 degrees Celsius. When your transformer nears this temperature, you want an overheating protection system to step in, alert you, and shut the transformer down. The longer your transformer operates above its maximum safe temperature, the more its lifespan will degrade. Operating above this maximum temperature can also degrade wire insulation, which can cause other problems down the road. In many transformers, fiber optic cables are used to measure the temperature in the transformer core. It's at the center of the transformer where you'll encounter the highest temperatures, which is why fiber optic cables need to access that area. Overfluxing protection. Just as overcurrent is an instance of exceeding the normal electrical current to a transformer, overfluxing is an instance of increasing the magnetic flux density to an extreme point. This increase can cause overheating and then internal fault, which can be very costly to repair. Overfluxing protection works similarly to overcurrent protection. When the flux density ratio increases to a dangerous level, the system will send a signal to the circuit breaker telling it to trip. This will shut down your transformer and prevent any further damage. Buchholz gas detection relay. A Buchholz relay is a specific system used to protect your transformer in the event of minor or major faults. When your transformer is operating as intended, the Buchholz relay will be filled with oil. If there is an internal fault, the Buchholz relay will instead fill with gas bubbles which are produced in the transformer tank. These gas bubbles accumulate until they trigger an alarm element in the Buchholz relay. If the problem is not addressed in time, the Buchholz relay will secondarily trigger a trip element. This occurs in the case of rapid oil loss due to serious fault. Oil temperature trip relay. This relay senses oil temperature when an internal fault like insulation failure in one phase of winding and shorted or a local hotspot is generated, so the produced temperature is transferred to oil and oil gets heated. When the oil temperature increases and exceeds a set value, this oil temperature relay operates. Winding temperature trip relay. Winding temperature indicator indicates temperature, which is proportional to load current plus top oil temperature of the transformer. The indicator is provided with 2 or 4 mercury switches. One is used for alarm, second is used for the trip, third for fan control, and fourth for pump. The temperature settings of the switches are different from each other for discrimination when the temp exceeds the max. Set temp the trip contact actuates and de-energize the transformer. Pressure relief valve (PRV). In case of a severe fault in the transformer, the internal pressure may build up to a level which may result in an explosion of the tank. To avoid such a contingency, a pressure relief valve is fitted on the transformer. Normally, the pressure relief device valve PRD will be mounted on top of the transformer if pressure arises inside a transformer and exceeds a preset pressure limit. The pressure safety valve PRD opens its valve flap, which is held by a spring and releases the internal pressure until it declines. After a decrease in the pressure valve flap moves back to its original position and closes completely.